A student balances a non-uniform object on a pivot. To do this, a weight is suspended near the left-hand side of the object as shown. Where is the center of mass of the object? This is a very straightforward question, I feel. So there's a force being acted on it over here because of the mass. There's a force. And because of this force, the pivot is over here and there's some distance. So it's causing a turning effect on this object, so to speak. Well, it is an object. So it's going to try to turn it which way? Counterclockwise. Counterclockwise, right? It's going to try to turn like that. Now, if you put, if the weight was over here, that weight would also produce a moment, right? That moment produced by the weight will also be counterclockwise, or CCW. So this won't stay balanced because you have to have a counter, or like counter for this counterclockwise moment, which is a clockwise moment. So it has to turn like that, the other way, right? We have to find a moment that's clockwise to balance it out, right? And we're not even getting to the right magnitude of it, right? So C will actually probably very likely not produce any moment because it's on the pivot. And why won't it? Because the weight is acting on it like that, so it won't cause any turning effect because it's not rotational anymore, right? If the weight was acting on the pivot, that would do what? Moment would be the force times d. The force is, well, for this case, is the weight times distance from the pivot, which is 0. So the moment is 0. Very cool equation when it works out that way. But this weight over here, if the weight is over here, and it kind of makes sense because it's bulging on this side, a lot more mass over here. So if the weight was over here and the pivot is over here on this side, this will create a clockwise moment. Only at D, if the center of mass is at D, will it create a clockwise moment. I think I said counterclockwise a few seconds ago. Clockwise, which is required for this to take place. So D is our correct answer. Let's write that down. D.